momentarily. I wanted to thank everyone for your time. Obviously, we have an opportunity to speak with Tony Hodgson, Ethar Incorporated. Recently added alliance partner for NCDMM. He's going to spend just a few minutes going through charts, talking about the history, capabilities, technologies, and current activities around things such as augmented reality, AI, spatial computing. Tony, you keep me honest here. I believe we first talked back in January 2025. You reached out to us, had interest in learning more about NCDMM. Obviously, we talked about the technology and your capabilities, and likewise our mission. Spoke about the alliance partnership, which we pursued that. I think that was approved in February 2025. So been great working with Tony to date on chasing some opportunities and thinking what the art of the possible is for collaboration and partnership. Just a quick note, background on Tony's behalf. He's the founder and CEO of Ethar Incorporated. It's a global service provider to enterprise clients, again, on AR, VR, and artificial intelligence, things such as emerging technologies and spatial computing. Began a career as a system engineer supporting NASA and commercial space programs, then became a global telecom solutions lead for MCI, product manager for Verizon, and also a tech entrepreneur. So over a decade of experience working with digital working technologies for applications in industrial, manufacturing, and utility fields. He's also a member of IEEE and a contributor to multiple standards of different development programs. So, all right, Tony, I believe the floor is yours, sir, if you're still there with us.
Great. Jamie, thank you. Hey, everyone.
Absolutely.
Thank you very much. Thank you very much. I really appreciate this opportunity. So we're entering an era now where the physical world's becoming instrumented with sensors, machines, and autonomous systems. And as everyone knows, AI agents are beginning to explode. Spatial intelligence, which I'm going to talk about here, is the operational interface layer that allows humans to supervise, understand, and guide complex AI-driven environments. This will make more sense here in a minute. In today's manufacturing environments, and especially in tomorrow's environments, sensors observe continuously and AI analyzes patterns at lightning speed. But humans still have to interpret meaning, set mission objectives, and make strategic decisions without faltering from cognitive overload. This creates a human-machine bandwidth gap, which is the difference between the speed that machines are moving at and the human comprehension speed. A challenge like this is common across many complex operating environments. Traditional interfaces in an environment are beginning to falter because AI chats, for example, interfaces fail because they're sequential and they're slow. And traditional dashboards, even digital dashboards, fail by themselves at a certain point because they start fragmenting the user's attention. But we are amazing animals as humans, and we have an extraordinary sense of space, the relative positions of things in space, and dynamic detection and prediction of moving things in the space. It's really almost baked into our DNA. Spatial intelligence systems close that gap between humans and digital systems by translating all this complex operational data into easy to interpret and manipulate spatial presentations. Modern organizations operations happen across the physical world, digital systems, and the human operator who's seeking to understand and act. Spatial intelligence connects all of these domains so humans can easily understand and guide complex operations. Let's consider a smart manufacturing scenario. Multiple systems operate simultaneously, like machines that are producing components, robots that are moving materials, conveyors are routing parts, and quality systems are inspecting the output. And each of these systems generates operational data, as we all know. Supervisors and engineers must coordinate the activities across the machines, processes, and production schedules, and field personnel on the shop floor have to execute in the real world with all the spaces, equipment, and tools that are around them. So traditional dashboards and reports can't really convey the full spatial and operational scenario that allows you to optimize performance and respond quickly. So spatial intelligent presentations and controls, because it's not just about presenting data, but it's also about being able to manipulate spatial displays and renderings and be able to feed back into the control systems for the real world. They elevate humans' capacity to absorb, interpret, and act on information. Here's a little short promo video that we did for our company. Sorry for the commercial for our company, but it explains this whole concept from a little different perspective.
You've heard of artificial intelligence or...
Oops. Let's go back to that and see if I can get the volume up. Oh, I think that's it.
You've heard of artificial intelligence, or AI, but there's another breakthrough transforming the way we communicate: augmented reality, or AR. Through the camera on your tablet or smart glasses, AR blends digital content with the real world in 3D space. An immersive new medium transforming how we interact with the people, places, and things around us. Ethar's intelligent AR platform combines AI and AR in a spatial toolset that is interoperable across devices and built to accelerate engineering design, worker training, and real-time decision-making. Across factories, healthcare clinics, and military bases, workers and warfighters face growing complexity. Doing the job on time, safely, and efficiently requires more than skill. It calls for intelligent support, delivered exactly when and where it's needed. We're partnering with American educators, industry, and government to develop the next-gen workforce. Our agile, affordable, and efficient spatial computing solutions help workers visualize the operational picture, reducing cognitive load and improving work quality. Ethar is on the launch pad for a new kind of space exploration to unlock the 3D realm around us as the next human interface to AI and enterprise knowledge. This is a dual-use technology with real-world impact. If your mission is urgent, we're ready to move. We seek bold customers and partners who are ready to go fast and think big. Contact Ethar to learn more.
So what we're really doing here is you all are likely very familiar with the OODA command loop, where content presentations contextually prioritized and giving decision makers synthesized overview. This also gives field actors actionable guidance with content, digital content that can be displayed on top of, superimposed on, in and around both natural and man-made features and objects that are in the surroundings. Data drives analysis and simulations. Spatial information helps the human comprehend it and guide the system, and actions are adjusted to optimize results. The spatial intelligent architecture stack looks like this. Down at the bottom here, we've got the physical world that's the source of data through all the IoT sensors, cameras, machines, and more that begin and feed the digital thread. Spatial intelligence systems federated across digital twins, analytical systems, simulation systems, simulate the chosen environments. Now here is the semantic spatial intelligence layer. The semantic inference engine, which is at the lower part here, is driven by organized data ontologies, and it provides models of objects, relationships, the real world space, and it does it by deducing the contextual operational states powered by AI and augmented reality, and presents the information that's gathered to the user for feedback. Finally, the human's empowered to communicate their intent and guide mission objectives and decisions. Here's an example of a system we built in our first NSF SBIR project designed for manufacturing workforce development. And what we have here are AI agents and knowledge engines that know about the space, they know about the user, they know about their capabilities and authentication, they know about the processes, and they then the semantic inference engine churns through and identifies information that the user needs to see. It projects that out into the real world and gathers input through a variety of mechanisms and provides step-by-step guidance then, which really speeds up capabilities for training new people, and also for people to be able to refer back to instructions when they need some additional guidance in the real world. At the heart of Ethar's intelligence engine, and any intelligence engine that's a spatial inference sort of scenario, are ontologies. And these are structured vocabularies that define the concepts and relationships so that people in software can interpret data in the same way. Ethar recently completed an Air Force Research Lab project to identify and characterize ontologies for aircraft maintenance and repair. We scoured over 130,000 research publications and reports to cull down to the 30 most relevant ontologies, and then normalized and graded them as building blocks for the given use case. This report is available to the public also. It's a very useful reference for people operating in a machine, a manufacturing and maintenance sort of depot scenarios. This diagram illustrates how spatial information really spans a scale and multiple domains, from global geospatial context all the way down to individual building components and hyperlocal in-the-room spatial volumes. This highlights the need for a unified spatial framework that can integrate GIS information, BIM information, CAD information, and operational data into a coherent model for decision making.
Hey,
In a
Tony,
related,
quick question, if I may, real quick,
yeah,
and
absolutely.
encourage everyone to jump in and ask questions. We'll have a Q&A at the end. When you talk about the previous chart there, the knowledge engine, and you talk about spatial domain layers, and you mentioned the report done by AFRL, how often does that type of data or information need to be refreshed? I mean, does it evolve over time? And I guess I kind of asked that question in terms of the cost associated with developing like an AR solution, right? Especially in a new industrial environment. What is the heavy lifting? What is the cost intensive activity here?
Yeah, it's a great question. So when it comes to the ontologies that are applicable in any given situation, there are different layers or levels of detail of ontologies. So there are high level ontologies that describe sort of across all of the possible applications. And these are the terms and concepts that humans and machines need to understand and agree upon how they're going to communicate. There are
Right.
mid-level. So, for example, manufacturing vertical would be a mid-level type of ontologies, and there are many different ones that have been created and are continuing to evolve. And then there are the lower level ontologies that apply really very hyper specifically to the use cases that you're trying to address if you're trying to engage something like this. So the power of ontologies and ontologies mapped into and embodied in knowledge graphs, which allow this churning through these different relationships of all these things to infer the semantic situation and what information is most important for the people and for the machines in any given time frame. Those have been around. The concepts have been around for 100 years, the past 30 years, people have kind of worked on it, but it's only recently that it's just taken a hockey puck curve upward, that with AI now, people are able to create those ontologies, customize the ontologies, weave together the ontologies. So it's difficult to say anything specific, Jamie, but
Right.
suffice it to say that it's happening faster and more quickly than ever. One of the things that's really nice is, as the industries or given user groups and communities agree on the foundational ontologies, then it gets faster and faster because sort of the foundation's already been laid. So there are DoD approved high level ontologies. The mid level ontologies are continuing to develop, and the hyperlocal may need to be developed by the particular design team that's working with it, but it's an important part. Once you have it, like that we have that ontology for that particular hydraulic press that we're working with, you can change the features and the procedures, and the ontology just absorbs it right away and is able to churn out information. So
Okay.
it's a great
That
question.
helps.
Yeah.
All right. Thank you.
Okay, in a related R&D initiative, Ethar led an industry study evaluating visual positioning solutions. So it's critically important, if you're using augmented reality, that you understand where in the world you are and where in a given space you are, and where all of the real and digital things are in that space. So we completed this study that helps provide an analysis of the different visual positioning systems that are out there right now. And we also helped establish an international standard with the Open Geospatial Consortium called GeoPose that defines the encoding for real-world position and orientation, 6 degrees of freedom, for both the real and digital objects in machine-readable form, so that systems operating in a given space can interoperate with each other related to the digital and the real things that are in the space. You could have devices from multiple robot arms and conveyor belts, all from different vendors, as long as they align with the GeoPose standard, then they can begin to interoperate. Now, AR systems that project and render digital content in the space do that with GeoPose relative to all the real world things that are also identified there. Here's another example of how we implemented an outdoor geospatial proof of concept that lets manufacturing leaders see facility operations and infrastructure in real-world spatial context. This makes it faster to diagnose problems and optimize plant layouts and logistics. This is there's no sound with this one. This is a satellite imagery and photogrammetry imagery of actually outside the Dynetics building here in Huntsville. And so you can see the map there, and then using the AR tools, a user is going to place markers at different locations in the real world. So this could be a manufacturing campus. This could be any sort of deployment environment where equipment's got to go out. Once you place the digital content, and we're just using simple cubes and blocks here, those things show up in the real world where you place them, and you can move them around, or you can move the markers around, or you can move the markers on the remote replica, and so you can see that you can move from one to the other. Of course, the information that we're presenting here are just point of interest markers, but you could have that be anything. It could be digital artillery pieces. It could be logistics, supply pallets, and being able to identify where things are and not only see them in the real world, but also see them remotely. Although, in that instance, we had the little, the tabletop map mode that we call it outdoors. That could have easily been, 1,000 miles away in someone's command room. Semantic augmented reality also closes the gap between requirements and verified execution. When people are wearing smart glasses, they have cameras on them. And by the way, you can operate many different types of AR software in this kind of environment using mobile devices, tablets, and headsets, and smart glasses increasingly, and certainly the higher powered augmented reality headsets. But they automatically capture evidence like completion states. They can take photos and videos. They can take measurements, timestamps, and operator confirmations that feed quality systems, traceability records, and digital twin updates. Of course, cybersecurity is always crucial, especially here in spatial systems, because they interact with sensitive operational data, digital twins, and enterprise networks. You can imagine walking around on a production floor in a fighter jet factory. It's gathering all kinds of information that you might want to make sure that you're protecting. And not only the digital information that it sees, but it opens up additional threat vectors. Well, we conducted what we believe to be the first ever research program. This was back in 2017, actually, contracted by the AR for Enterprise Alliance, which is the largest member organization focused on enterprise augmented reality. And in that project, we identified all the different cybersecurity risks that we could identify, and we developed guidance and an operational framework and a test protocol for securing enterprise AR deployments. Now, I'm going to show you a NIST video, actually produced by NIST, but this is a functionality and code that we're working to embed in our platform in order of in our roadmap. This is on there. We haven't begun this yet, but you'll see how this can really save thousands of dollars in quality control costs if you can enable this for your operations. So here's a
demo video
I
for the
forgot there's
paper titled
audio with this. I don't know if you'll be able to hear it.
Product definitions in augmented reality. As you can see, once the physical part is detected and tracked, the part geometry as well as the graphical PMI annotations are drawn on top of the physical piece, which you can then interact with in real time. On the left-hand side, you have a list of toggles which can be used to individually toggle on and off views, as well as the part geometry.
Another important part about this solution that they built is that these callouts that are industry standard in terms of their dimensioning and style, they color coded them. So after a person creates a part or the machine creates a part, you can superimpose the CAD model over the part, and where the part and the CAD model line up, you would see green callouts. Where there are potential issues, they would color them in a different part of the video. They color them yellow. And then where there are concerns that don't seem to match or match within the tolerance that they're able to measure, they show up as red. So, hugely valuable to be able to spatially look at something and very quickly determine where potential QC issues might be present.
Hey, Tony, question for you on that.
Yes.
Brian out of the Huntsville location.
Hey, Brian.
The tolerance, can that stuff be tracked, recorded for, say, ISO or AS9100 requirements, QMS requirements?
Certainly anything that's captured by video by the headset can be recorded, and it can be maintained for posterity. And I would suggest that with a little bit of work could even be analyzed, and what you see could be mapped into the specific forms and formats that are necessary in order to do the reporting. So the video can become an artifact that is evidence associated and attached to the certifications, and could be used as a source for extracting information that can then feed right into the forms. That's one of the huge things about AI that's happening right now, is the ability to analyze something like this and pull that information out.
Well, thank you. And
answer the question.
It does. And with that recording, if that was a serialized part, can it recognize that serial number and then save it under that to create a digital cloud for that part?
Well, the answer is it depends, but I can tell you this, that we've created in another instance for Alabama Power. They have a gas urban plant, and the workers were going through the plant, and they were having to do their maintenance rounds, and they would have to write down these complex serial numbers, like 16 digits for each thing that they did, and we just enabled it so that they could just point the camera at the serial number. It immediately, did text recognition, and then linked them to the data that was relevant to that particular asset that they were looking at. So, if depending on lighting conditions and how large the serial number is, but if you can get it in the camera, then we could probably capture it. I have a high degree of confidence that we could capture it and then use that material or that information.
Perfect. Thank you.
Absolutely.
Nick, I think I saw your hand. Yep, go ahead, sir. Sorry.
Yeah. So I was just going to follow up on Brian's question a little bit there. So that's in terms of extracting dimensions from that to compare to the print. What types of tolerances were they able to measure against with a visual cameras? Because I'm assuming there's no blue light type of filter on that's just a regular visual camera image that it's comparing.
Right. So that's a great question. And of course, we would want to know, that. What I can say is it's not going to measure down to, tenths of a millimeter or less, but it could probably get within, sub-millimeter if the headset and cameras that you're using on the headset are high enough quality, and the lighting conditions and the user, if the user's moving it around rapidly, it's going to be more challenging. But if you hold it in the right position, or move your head so that it's in the right position, I would suggest that probably millimeter and potentially sub-millimeter. So it's not going to get down to 1,000th of a millimeter.
Okay, thank you.
But it can rapidly identify more gross anomalies. Let's put it that way. Yeah.
Gotcha. Okay,
Yeah.
thanks.
Tony, I think you got one more question. Basu,
Yeah.
please go ahead.
Hello. Oh, can you hear me?
Yes, we can.
Mm-hmm.
So the what you're showing right now, is that basically identification and labeling based on a CAD drawing, or is it actually measuring it?
What it's superimposing on there are dimensioning data that come from the CAD drawing.
Okay, so it's not a measurement; it's basically a superimposition based on some sort of a retrieval mechanism of the data. Correct?
Yes, exactly. Yes.
Okay, thank you.
Yeah.
Has there, just a follow up on it, has there been any advancements on doing the measurements? Maybe that's what the last question was about.
I don't know of any specifically, but it certainly it begs for that to be like the next most important thing that one would study if they had research funds to work on this particular item. What would it take in order to get the necessary precision for the parts? Really an important area that either someone's bound to be working on already and I don't know about it, which is very likely, or it hasn't been started yet, and I'd love to work on that with you guys. Okay, let me go to the next slide here. So I'm going to show you another video here. Now, this is an example of a facility mapping. Like, it could be used for a variety of reasons. Space planning is one, but in this instance, what's happened is we did this project for one of our clients. This is actually a a full floor of one of Chevron's headquarters building facility in Houston. And what we've done here is we had to ingest the CAD model. We had to optimize it, and then we superimposed on it this heat map. You can see these yellow lines, and then you'll see little blue icons at various locations around the model. And this is the wireless network that they were going to build into this floor so that people had both mobile and Wi-Fi connectivity wherever they went in the facility. So they laid it out. They put in the wiring and the devices where they expected them to go, and then they use analysis software to simulate what the coverage would be, where are the dead spots, where are the hot spots, and then you could go on and redesign as necessary. Now, this is showing the next phase of the project, or it's indicating the next phase of the project that we intend to go to, which is being able to walk into the real world facility, have the system localize where you are, and then be able to project all the digital content of the infrastructure so that you could just walk through and you could see where the cabling is in the ceiling or where it's supposed to be in the walls and the floor. You could add annotations. And as soon as if I'm a wiring crew walking through, or I'm a plumbing, or I'm the fire suppression system specialist, and I see something that needs attention, I could annotate it. And as soon as I change anything in the real world digital assets that I'm working with, or I add a note, then anyone who has access to the remote facility model, wherever they're located, would also see that pop up. So let me just hit it again here real quick. Of course, you can turn layers on and off, and then add additional. We're doing a heat map for a radio frequency. There's all kinds of usage information and really important manufacturing environment, logistics, supply, that kind of thing. So, combination of
Is it me, or is there volume problem or issues?
No, same here.
There's issues.
Yep.
Do you mean with me or with the video?
Tony, I think your video is consuming your bandwidth.
Yeah, you're breaking up.
Wait, let me show you. You don't need to look. Let's see here. Where'd my note go? That's not it.
You're still breaking up on it, Tony, if you got the video stopped.
Hang on one moment. Okay. Maybe I'll share this thing again.
Still choppy.
Still choppy. How about now?
It's a little bit better. You're frozen on the screen.
Two that fiber coming in my house, so it's open it up. Okay, well, it's not helping me. Try something else. We're on slide here.
Maybe shut off your camera.
Yes, I did. Can you see?
You're
Okay,
much
can you
clearer
see it
now.
now?
Yeah,
Okay,
we
good.
can hear you as well.
Okay, so the bottom line is that semantic augmented reality and spatial intelligence provide a new layer for operating in the real world, and particularly with all of these AI and other automation and simulation and measurement systems that are out there. Increasingly, that data and the speed at which all of this information is going to be coming at people is just going to be getting really radical. So somehow, if humans if humans are still going to be involved at all in manufacturing operations, then the role that they must play is to monitor and then be able to issue commands and direct the systems spatial intelligence, in addition to whatever else, what other interface you might use, spatial intelligence and being able to map data out in a spatial fashion and be able to work with it and manipulate it, particularly if the system prioritizes, it doesn't just show you all of the data, it shows you the prioritized data because you have semantic understanding of the system has a semantic understanding of your particular role and your particular situation. So spatial intelligence provides the interface that allows the humans to supervise and guide these AI-driven environments. A super exciting time. All right. Thank you very much. I appreciate you riding with me through difficulties here, technical difficulties, and my own presentation difficulties. I'm open for questions if you guys have anything.
Tony, I got one question. Maybe a couple others have one here in a second. You mentioned the video you showed in the NIST code per se, I think is what you said. Is that something that's publicly available, or will you have to create that code for your own applications?
Yeah, no, the NIST code's publicly available and it needs to be integrated into some kind of system that can be applied in a particular instance. Okay, it's general code that's available.
Okay, that was my thought. I just want to make sure.
Yeah.
Phil, I see your hand up, sir. Please go ahead.
Yes. Is there a altitude limit on like you were dropping those dots on there along a pathway? Is there an altitude of how high those things can go?
How high the
marker itself?
The digital rendering, how high they could go? No, there's not. As a matter of fact, we now likely you're talking about something that might be even more than this, but we did some work for actually a music festival down in Lafayette, Louisiana, and there was a particular venue, and we projected digital content up in the air about 500 yards up in the air. So from blocks away, you could see that. If you had the app, you could see the content there. So what is the use case that you're thinking about?
Airspace.
Yeah.
For pilots, for like general aviation too. So you could mark airspace if you want to toggle that on and off, so you could have a visual with it instead of trying to interpret it off of your moving map screens itself.
Sure. I think that'd be really a valuable use case, and it would take a lot of work to put it together, but there's conceptually no reason that couldn't happen. Now, we've got companies like Anduril and Palantir that are at the bleeding edge of AI and augmented reality and putting headsets on into fighter jets for the fighter crews that show both real time and for training purposes, enemy aircraft and other information. We're not going to probably get to that level of sophistication. $100 million. We're happy to work with you on that. However, those use cases are the top of the pyramid.
If you can hear me, Tony, you're breaking up again.
Okay, great. Go sharing right now, and that'll help. All right, can you hear me better?
Still choppy, just a little bit.
Something's pirating my bandwidth. I have to check with the neighbors. Can you hear me now?
Yeah, it's still a little bit choppy, but we can hear you.
Okay. Yeah, so at the highest end of application possibilities are those very dynamic, near real-time situation use cases that cost a lot of money and take a long time to develop those.
I think we're losing you completely almost, Tony. If you can still hear me. Are you still there? Guess not.
So much for 2 gig fiber.
That's right. Good old
Okay, how about
technology.
now?
Hey, there you are. I can hear you now.
Don't tell anyone that I'm part owner in a technology company. Yes.
We know.
Yeah.
Trust that everybody
Yeah.
on this call has experienced the same situations. You're not alone. So,
Yeah.
so.
Yeah. So anyway, what I was saying is, the real-time high-end systems are very expensive and very challenging to build. The rest of the 90% or the 80% of the pyramid of possible use cases are much more realistic. And that civil aviation use case that you described with static, relatively static airspace visualization, the airspace doesn't necessarily change moment to moment. So I would think that that'd be entirely possible. Yes. Question.
Yeah, can you hear me?
Yes.
So could you speak to a little bit from your experience and what you've seen there, related to how these systems that are in production applications today, if you focus on manufacturing, for an example, how the return on the investment and the business side is being justified. So some context. So my understanding is you can typically use this for marking and superimposition type applications at a very high level. So I'm trying to understand how does that get turned into some sort of a value from a business point when you're have it implemented. If you can speak to that a little bit, thank you.
Yeah. So there. So I'm going to answer it a couple of ways. There are a large and growing number of case studies that are out there that document the return on investment that various enterprise organizations have seen by implementing these type of solutions. There's also this organization that I talked about, the AR for Enterprise Alliance, which you can get to and learn more about by going to thearea.org. They've spent a lot of money to develop ROI calculators that can be used to help with specific instances. Now, just last week, actually, I was visiting the Boeing aircraft engineering manufacturing facility in Long Beach, California, and I was meeting with the head of the augmented reality group there. And they have implemented an augmented reality system that's one of the more advanced ones that I've ever seen. And they're using it for quality control purposes. So when a wing spar is prepared to move from one state to the next workstation or work cell, it's important that particular piece parts are positioned where they're supposed to be. And so their system uses CAD models, and it also uses photogrammetry. They've taken real parts and they've taken hundreds of pictures of the parts and molded that into an object model. And their system uses object recognition to identify the different parts that are on the wingspan, and it counts them and it identifies them, it records it by video, and then it also pulls up additional models. There are waypoints at which each person who's doing the inspecting is supposed to identify specific information and load it into their system in their prescribed forms. And so it gives them a notification, hey, here's where you need to do one of those things. And they touch it and it gathers the information that's necessary and it feeds it right into the form in the digital form. And they have told me directly that there have been instances where a wing spar moves from one position in the factory to the next position, and it does not have all the parts on it that are necessary. Additional construction continues, and then they find out that something's wrong, and it's costing them hundreds of thousands of dollars to bring those spars back and do the repair work that needs to be done. So, that I can put you in touch with real world people who've had real world use cases on production airliner manufacturing, who've seen, this kind of ROI. I don't know if that is a complete answer, but hopefully it helps a little bit.
Yeah, thank you. So you said there's an ROI calculator. So I was able to find that. What's the other resource you mentioned?
Use case, like case studies. There's a portfolio of case studies about ROI for enterprise grade augmented reality. ExxonMobil did one. Boeing's done actually several. Medtronic, that does medical device manufacturing, has one. And I'd be happy to pull some and maybe provide them to you, or help you if I could understand a little bit better what you're looking for, whether it's a specific use case or you just like to arm yourself so that you could perform ROI calculations in the future and understand what goes into them.
Yeah, I think that's fine. Thank you. So it's Medtronics, Boeing, and what's the other one you said did a use case study?
ExxonMobil.
ExxonMobil. Okay, thank you.
Yes.
Okay. Well, Tony, despite the technical issues, you did a great job. I think we may have a moment just for one more question if anybody has one. No? Sounds like everyone's satisfied. Tony, you can still hear me, right?
Yes, sir.
All right. Fantastic. Okay.
Okay, great.
Well, I do appreciate everyone's patience as we fight through the IT stuff, but we made it through. Tony, great job. Appreciate you taking the time to put together information and share it with folks. It's been great working with you. Look forward to the future, opportunities for collaboration. I encourage the folks that are still online from the NCDMM side, don't hesitate to reach out to Tony at any time. If you have questions, I can gladly connect you with him if need be, but I know he's eager to learn more about us and seek out opportunities. So.
Yeah, thank you very much, Jamie, and thank you, everyone. Appreciate it and look forward to talking more.
Yeah, absolutely. Thank y'all so much. Y'all have a great day.
Bye
Thanks,
now.
Tony. Bye-bye.
Mm-hmm.